Welcome back again, 8th graders. We are in week 7, lesson 3, and we're only on textbook page 359 today. Ready? Here we go. All right, let's start off with a little quiz. What are two types of global winds? A, local winds and wind belts. B, calm winds and wind belts. C, calm winds and angry winds. Or D, calm winds and sea breezes. 5, 4, 3, 2, 1. I'm going to eliminate calm winds and angry winds because I made up angry winds. So that's not right. I'm also going to eliminate local winds and wind belts because local winds are winds that blow over a short distance only, and global winds are winds that blow over the globe. So if we're talking about global winds, it's a much bigger scale than local winds. So the correct answer is calm winds and wind belts. The reason why it's not letter D is because sea breezes are actually a type of local winds, if you remember. Okay, so what are we going to do today? Today we're going to learn about jet streams, but unfortunately not those kind of cool fighter jet streams. We're going to be talking more about wind, so sorry to disappoint. So jet streams, they are high-speed winds that are about 10 kilometers off the ground or about 6.2 miles high. They generally blow west to east, and as they travel, they sometimes wander north to south in a wavy path over time. So, like when I walk, I kind of lose track of where I am, and I don't really walk in a straight line, and then people next to me are getting annoyed because I keep bumping into them. Jet streams are kind of the same way. So here is a GIF of a jet stream. It's in that kind of like blue, yellow, green, and you can see how it's kind of in a wavy path. It doesn't really stay in one place. Okay, so jet streams and local weather. Why do we care about jet streams? Well, they greatly affect local weather, so weather forecasts try to study them. So this is the guy that or woman that shows up on your screen, and they're like, hey, it's gonna rain, it's gonna snow. And they need to understand these because we can use them to predict temperature and precipitation. Precipitation is just a fancy science word for rain. Let's see how exactly jet streams can affect local weather. So I have two pictures here side by side, A and B. Picture A shows an average polar, that means from the pole, jet stream path over North America. So that's in the yellow arrows. That is the jet stream path. Please remember that the poles are generally colder than, let's say, places closer to the equator. So this is going to be a cold wind blowing in. So picture B shows the same jet path that has traveled more north. So remember, it's like when you're walking with me, I am all over the place. So the jet path is the same. It's going to be a little more south, a little more north. So in this particular case, in picture B, it has meandered or traveled more north. So what's going to happen? Well, because it moved north, the warm air will rise from the south. So what do you know about the south? Something nice about the south is that it's warm. So all of a sudden that icy line of polar air has moved up more. So what's going to happen is all that warm air for the south is also going to travel up. And what that's going to do is the states that are below the jet stream are going to have a warmer winter because all of that hot air is coming in from the south. So let's go back to picture A, and I put a white circle where Chicago, the city of Chicago and the state of Illinois is. And what do you know about Chicago? It's the windy city. It can be really, really cold, almost as cold as Buffalo. But if the jet stream was looking like this, as it is in picture B, you're going to notice that Chicago is no longer right on the polar jet stream. It is way below the polar jet stream. So people in Chicago are going to get lucky because it's going to be a much warmer winter because all of that heat is coming up from the south, and there isn't I almost think of a polar jet stream as almost like a fence that's going to block heat. That's not going to happen because that jet stream has traveled so much farther north. Okay, so let's try to put what we just learned into action. So this is a picture of your textbook, and I want you to look at the polar jet stream, which is in purple. It's also labeled. and I want you to predict if the city of Cheyenne, which is right here, will have a colder or warmer winter. So A, if you think it's warm, it's going to be a warm winter based on the polar jet stream. B, if you think it's going to be a colder winter. So I always like to put up our compass so I know what direction I'm looking at, and I'm looking at Cheyenne, I'm looking at the polar jet stream, and I realize that the city of Cheyenne is north of the polar jet stream. Okay, also please remember the polar jet stream almost acts like a border or a fence that will kind of stop the warm air. So all of that nice air coming from Mexico, Florida, Texas, that's going to get blocked, and there's not going to be, that heat's not going to travel because that polar jet stream's acting like a border. So what do you think is going to happen with Cheyenne? It is now north of the polar jet stream. 5, 4, 3, 2, 1. Correct answer is colder winter. Again, that polar jet stream is going to act like a border that stops heat, and it has traveled so far south that unfortunately most of North America will have a cold winter, according to this picture. All right, guys, that is it for now. Yeah, I'm pretty done. All right, I'll see you back here soon.